All right, so I'm continuing with this data. It might not be visible on the screen. If you have this written down or you're following the example in the book, it'll help. What we're going to do is we're going to make some different graphs based off of this frequency distribution. And what we're going to try to do is use it for a way of visualizing the information and the patterns that we can see in the numbers. So the first thing I'm going to do is I'm going to draw a set of axes, and we're going to use it to make what's called a histogram. So just remember that's the data that we're using. And so I'm going to have my y-axis here, and I'm going to have my x-axis here. And I'm going to separate this into data locations that really represent my bins. Let me see if I can. And then I'm going to have places for my counts. I'm going to need to be a little bit bigger here. Right, you have graph paper, it goes a little bit easier than me drawing on the screen here, but it'll be enough to get the idea of what we need to do. Now I'm going to use the midpoints to label these, and the midpoints just make the labeling easier. So the midpoint of this bin, or I'm sorry, this class, was 172.5. The midpoint of this one was 208.5. And I'm just going to keep doing my labels here, so I'll write them all in. And these will be my counts, my frequencies. And what I want to do is really color in a rectangle as a bar for each one of these. So my first count was 3. So I have a bar that's 3 high. My second count was 2. And my third count was 5. My next count was 6, so I'll keep going here. And this highest one was 7. And the second to last one was 4. And this last one was 3. And this is a histogram. It really looks like the tally marks we made, and the height tells me the count of my data. And if we shade it in again, we can see most of my data is in here. And we have a pattern of where our data is. We can see how it's spread out across all the values of the range. And so this lets us visualize how that data was. And so this is a frequency histogram. And this is one of the most powerful tools that we can use. Frequency histograms are really common in the sciences to look for data and how it's spread. Now, there's also a frequency polygon. And I'm going to do this polygon on top of the histogram. What the polygon does is if we take the midpoint and the value here and we draw dots to them, we can play connect the dots. Oh, and on the graphs, there's usually a break listed in the bottom corner. You don't always see this, but this is letting us know that we're saying that this isn't 0, 0 like in most graphs. And what I can do is when I connect the dots, I have 0 values and I rise up to 3. Then from 3 I go down to 2. And playing connect the dots here. And then when we leave, it leaves down to 0. And this connection of lines is called a frequency polygon. So I'll write in purple, I guess, is the frequency polygon. I see frequency polygons more in business, and I see histograms more within the sciences. They give the same information, they give a shape. The frequency polygon tends to cut off the corners in histograms and hints at a smoother function. Now, we could also do this by relative frequency, and the only change with relative frequency, so I'm going to change my wording here, is instead of doing my counts up the side, instead of counting up the side here, I turn those counts into relative frequencies. So 1 divided by 30, this was my 0.03, and let me get my relative. This was my 0.07. This was my 0.1. This is my 0.13. So 0.17. 0.2. 0.23. And we don't have a 0.27, and what we've done is we've turned, instead of counting here, what we have is the count divided by the number of items. And so we can think of this as being percentages. And so the shape actually doesn't change, but what we're measuring on the y-axis changes. And so that is our frequency polygon and our relative frequency. The other thing to note on these graphs is these endpoints in software, because they have to touch. And when we did 190, we had 191 to we had 155. Let me scroll back up here. We had 155 to 190. Well, that would leave, and then in 191 to 226, that would leave a gap between these. And so the actual numbers that we get here, we have to smooth out. And so this comes right before 155. And so we have to subtract 0.5 from the lower boundary. So it's 154.5. We subtract 1 from the upper boundary, so it's 190.5. And so on and so on. And so to make this smooth and to transition smoothly between each, we have to take off 0.5 from each of these. Or, I'm sorry, put 0.5 off the lower end of each of these, because these lower bounds will subtract 0.5 from. And this is on example 3 in the book, and it redefines the class boundaries. And what it says is we want to get rid of this gap between 190 and 191. So I'm going to make a quick little table of the class boundaries down below and label it on my histogram. So I started with 155 to 190, 191 to 226, 227 to 262, 263 to 298. Now I'm just copying down what I had on the table. 299 to 334, 335 to 370, and 371 to 406. And so to get rid of the gap in between here, this has to go back a half, and this has to go forward a half. So what we do is from the lower bound, from the lower limit, we subtract 0.5, and from the upper limit, we add 0.5. So 155 minus 0.5 is 154.5 to 190.5. And then we're going to have 190.5 to 226.5. And then we're going to have 226.5 to 262.5, 262.5 to 298.5, 298.5 to 334.5, 334.5 to 370.5, and 370.5 to 406.5. And so notice now there's no gap from here to here. And that lets us put the edges of the histogram together. And so I can replace my edge numbers here. So 190.5, 226.5, right? These are my edges here. 262.5, 298.5, 334.5, 370.5, and 406.5. And I'll just pull, those are these numbers down here. And so our class boundaries, if we want the histogram to be smooth and not have any gaps from it, we have to push that up by a half and push that down by a half. And that ties everything together. One last thing that we can do here is we can make what's called an ogive. And an ogive is a frequency distribution with its cumulative frequencies. And so I'm going to make another graph for this, and I'm going to use these new class boundaries on it, and we're going to talk about the number of things we have at each class boundary. So remember, when I described a cumulative frequency, I talked about how much stuff we had up until the end of the class boundary. And so we can do the same thing here. So now my counts, I'm going to do by fives, because I have to get all the way up to 30 to get a cumulative distribution. So 5, 10, 15, 20, 25, 30. 30 is our top. We have a broken because we're not at the axes. And we're going to start with that 154.5. And we're going to move over to 190.5. So notice I'm using the class boundaries that I've recalculated here because I want them to be smooth. 190.5, 226.5, 262.5, 298.5, 334.5, 370.5, and 406.5. And so the cumulative frequency, when we get at 154, when we start at the lower boundary, there's been 0. When we get to the end of the first class, we had 3, because that's what the cumulative. When we get to the end of the second class, we had 5. When we got to the end of the third class, we had 10. When we got to the end of the fourth class, we had 16. 16. About there. And when we got to the end of the fifth class, we had 16, 23. Up to 23. 23-ish. And when we got to the end of this class, we had 27. And when we get to the very end, when we're done with all our data, we got to 30. And then we play connect the dots. And this is called an ogive. And it represents a cumulative frequency distribution. And so these are the graphs that we can do. Next module, we're going to let technology do some of this for us. All right, this is the end of chapter 2, section 1. I want to stop the video here, and then I'm going to move into some other graphing techniques for section 2.